Hey guys, welcome back to the fourth day of our webinar this week. I went ahead this morning and posted the webinar video and audio from yesterday's session. It's on our website, same place as all the other files have been. I just added a couple of data files for you guys to use if you want to look at this information later today or while I'm going through the session. It's on the web page. It's under data files for day 4. Today we're going to be going over wave grids, creating the wave grids, and I mentioned earlier that right now the wave grids are only available to be run with the variable spacing like we did on Tuesday for the flow grids. The telescoping availability is not ready for the wave grids, but hopefully in the next little while we'll get that, maybe in the next year. We're going to be covering creating the wave grids. It's very similar to what we've already covered, so that'll be a good time to go back over some of that same information. Also importing wave spectra from buoys and gauges, and how to create wave spectra energy files from just the bulk criteria. And if there's time, probably go over a little bit of how to make the CMS flow, CMS wave grids interact with each other through a long simulation. So are there any questions from you guys for anything that we went over late yesterday afternoon? Anything I need to go over real quickly before we get started on working with the wave grids? If so, just post your questions and I'll try to get back to them shortly. Like I said, the data files that I have for you guys today are in a zip file called wave.zip, and they'll be put into a wave folder. It's a few files here. We'll be working with all of these over the next couple of hours, and let's just go ahead and get started then. So just like working with the flow grid, basically you start out with a fresh SMS, or you can load your other information back in from working with your flow grid. There's a few different ways to build wave grids, and I'll go over a couple of them today. So looking in that wave folder, I'm going to grab our merged bathymetry that we've used a couple times. I've actually modified it a little bit and taken away some of the extra points that we don't really need. I've got it a lot closer down to the area that we're looking and interested in. So I'm going to turn on looking at the contours so I can actually see the bay. So I go into display options, contours. I'm going to choose color fill, specify my range. I've done this a few times, so hopefully you guys have got the idea of how to change these contours. And then tomorrow we'll go into a few of the other display features for showing various contours and vectors, different palettes for looking at magnitude differences, things like that. There's a question from Mark, who's asking if there's a help document for the website like we had for the first couple of days. I don't have one of those ready right now, but I will put one up there on the site. I'll let everybody know where when that material is there. We're taking a little bit of this material for this webinar from a couple of different workshops that we've done, and it's got some other information in there that's outdated, and we're trying to make sure that you guys have the most recent. And so it may take us a little while to get the other document up there and available. But it will be similar to the ones that we had for the first couple of days, either a presentation or even a hands-on step-by-step process. So I've got the bathymetry loaded, and I can zoom into our area. And so just like we did for the flow grid, what we need to do is to create a new coverage in the map module, and I'll name it Humboldt Bay Wave, because we're actually going to be building a wave grid today. And then we move down into the models and look for CMS wave instead of CMS flow. And so they're very similar, but there are a couple of differences, and I will point those out to you as we move along. So just create this coverage. I'm going to change my display options just a little bit more, just so I can remove all these digits of precision on that legend. Somehow I got 20 in that precision. So now what we need to do is make sure that the wave coverage is selected. Then we can draw a wave grid frame, kind of like we did for the other. Another thing I'm going to do real quick is go back into display options and turn on some transparency like we've done a couple of times, just so that we can see the grid frame and the refined points without having to look really that hard for them. So let's create the grid frame with the Create Grid Frame tool that's right here. And what's different about the wave grid as opposed to the flow grid, the wave grid has to have a certain orientation. So for the waves to work properly, you need to start your first point, the point of origin, needs to be in the open water, no matter what direction the waves are propagating. If you're on the East Coast or West Coast or in the Gulf of Mexico, the Great Lakes, always start building your grid frame for your wave grid in the open water. So we build that, and I've missed a little bit of the bay, but that's no big deal. I can move this grid frame later on. So I've got the area now that I want to create the grid frame for, and I can actually extend that back to get more of an area. And so we can do something like this as for our grid frame. The reasoning for starting all of your grid frames for the flow grid, for the wave grid in the open water, is because the way the wave model works, basically it starts at the point of origin on that last row, and it starts marching in one row at a time and working through the energy and the depths and changing the periods and directions and the intensity of the waves as it marches towards the shoreline. So it has to know where to start these waves from. So now that we've got that built, like I said, you can move this, you can rotate it, just like we did for the other grids. But this is going to be sufficient for what I need for right now, so I'll just move forward. The next thing we need, just like on Tuesday we covered, we need some ways to specify an increased resolution. You could go ahead and make this into a grid if you wanted to, but that would have constant spacing at some preset interval that you specify. And that's not necessarily the best way to do it. You don't really need a lot of resolution throughout the entire grid. You just need enough to represent the wave processes as they come towards the shoreline and through the inlet. So let's go ahead and create a point. So over here, actually let me make sure I'm in the right map data module. You can always see that it's feature objects, that would be the map data. We'll create a point, and I'll zoom in, and I want certain resolution through the inlet and maybe through a couple of these. I don't expect the waves to propagate this far up, but you never know how far they might go depending on the size of your bay. So let's just go ahead and add a little bit of resolution in just to make sure they can get as far as they need to. So once those points are created, we can select them individually or as a group and select and give them an attribute as far as the refinement level. And I'm not exactly sure what the best choice might be, so let's actually just measure. There's a measurement tool here on the lower toolbar here that's for computing measurements, and I'll just see how far it is across the inlet here. So I'll click first and then double click the second. I see it's about 660 meters. That's pretty wide. So let's make about 30 meter sails across this wave. It could be probably a little bit larger. So let me reselect these points. Right click, set the node attributes, and we're going to choose 30 meter spacing. And this is another thing that you could play around with if you didn't know what the distance across that was and you wanted to try different levels and see, you know, what the waves did with a 30 meter versus a 50 meter spacing. That's all things that you can change and rebuild your grid, just like we've shown the last couple of days for your flow grid. So with that done, let's go in like we've been doing, and under feature objects there's the same name. It's map to 2D grid. So everything so far has been pretty much the same process that we used for the flow, except for the fact that we must start in the water. And on the west coast it's no big deal because we've been starting in the lower left-hand corner anyway, but in all the other locations around the globe, you need to start in the appropriate location. I do have one question. Let me see. So Vincent's asking, what should we do with the grid if, for example, the waves come from the east, southeast, or the southeast? We would have a part of the grid starting from land. And that's a good question. Basically, I'm going to cancel this. Basically, the CMS wave is a half-plane wave model right now, and so that means that the waves can come anywhere from about 85 degrees normal to shore and negative 85 degrees, so any range in this direction. They would still propagate from the offshore edge, but the waves could be coming at a very oblique angle. If you had a situation where you needed more waves coming, say, from the southern edge, I suppose you could change your orientation a little bit of your grid and reorient it just so that you get a little bit more of an angle. But I'm going to let Liwa, he's the wave person. Normally everything we do is pretty much parallel to the shoreline, and something like this may or may not be the best approach. But if you needed more of a direction from that way, this would be one way to do it. So I'm going to go back to where I was there. And we probably don't even need to represent this entire grid in our grid frame, mainly because the fact that the waves will not propagate up into this bay very far, I would think. But we can always try it first and see how many cells it creates, and then if we wanted to cut back because it's taking a long time and we saw from a first approach that the waves weren't getting any farther than, say, here, we could cut some of this information off. We're mainly interested in the interaction with the flow on the open face and through the inlet as it's going through these channels. So, like I said, once again, we'll come back in and go under Map to 2D Grid. We have the same options as we did before. It tells us what the origin is, what the angle is. Some people try to clean this up a little bit, making it, even numbers, something like this. But it's not necessary. You can go with whatever you want to. We want to have a maximum cell size, and yesterday we were using 180 meters, and we can use the same thing today if you want. We could go up from that. We will be using refine points, so let's make sure that that's selected. I'll enter these values again. And I'm just going to leave the bias alone, turning off these checkboxes for the inner growth. As I specified the other day, that inner growth means that between where I have the refine points, the spacing will be kept constant as much as possible. They will not grow larger than a certain size. So for the depths, we're going to specify using a scatter set and select a certain scatter set that's loaded. And if you have multiple loaded, you want to make sure you choose the right one. You want to make sure that you choose the right datum if you have more than one datum listed in that data set as well. We have an extrapolation value, and I'll just put a certain value. It doesn't matter what this is. It needs to be something higher than water, so -2, -5, something like that would be appropriate. I think I normally use -2 on the West Coast. So now we can click OK. And then I'm ready to click OK again. It says the selected scatter set has disjointed vertices. And I think what that means is that there's some points in this grid that aren't fully connected, but I think everything is okay in the area that we're wanting to look at. So I'll just say yes for right now and see how everything appears once we're through. I'm going to pause for just a second, and I'll be right back. Sorry about that. And I've got to unmute again, so I don't know what's going on with the software. Sorry about that. It's always something with this. Sorry. So we should be going now. I hope everybody can hear me at this point. We'll get this under control for next week's webinar. Too many interruptions, I think. So I'm back looking at the new grid that I just created. What I did was I went through and changed the resolution to 50 meters through the inlet instead of 30, and that's a little bit more appropriate here. We don't have so many cells, and that'll free up a lot of the cells that were in the whole grid. So the next thing we do is we can turn that back off again for the cell edges. And so now we've got a wave grid that we're ready to use, and that's pretty much all you have to do. So it's essentially the same process as we did for the flow. We just need to make sure that we choose a wave coverage for the map module, and also to start the offshore edge for the wave grid. Now, there are a couple of different ways that we could do this as well. So this is one method for generating the wave grid. Another method is to, I'll go ahead and delete this. So we could, if we have already created a flow grid that uses variable spacing, we could actually load that CMS flow grid. It's got a little bit larger scale here. I'm just pulling one that we had previously done. So I'll lose my map data here so it's not in the way. So if we have a flow grid and we want to just use the same exact grid for our wave grid, it's no problem to do that. What we can do is to click the flow in the data tree, you right click, and you can actually, let's duplicate this. So we're creating another exact grid of this flow grid. And so we have now a flow grid copy. And I want to change this flow grid under Data, Switch Current Model. We can change this from a flow grid to a wave grid. And so now this flow grid is now a wave grid. If you see at the top, it shows CMS wave, and this one shows CMS flow. And on the West Coast, that's pretty much all you need to do. One thing you need to be aware of is to look at the IJ triad and make sure that the point of origin has the positive I direction going towards shore. So that would be for the flow grid, it's in that location because it's always in the lower left-hand corner. But for the wave grid, it must be in this location because it could be at any one of these four corners. So we've got everything situated, no problem. We can rename this if we want to be wave. So that works on a West Coast case because the point of origin was already on the water side. But what happens if we're somewhere else in the United States and need to create this wave grid from the flow grid? Well, one way to do that is once this is a wave grid, if the point of origin was in the wrong location, we could right-click on this wave grid and create a transformed grid. So the transformed grid comes up with this dialog. and I don't know why it overwrote that. I can't see it now, but let me go back in there. I will create a transformed grid, and it's showing that presently the current eye direction is from this direction moving towards the southeast, and if we wanted to change it going in any of the other directions, we could just change this rotation and see what the resulting direction would be for that modification. And so if we wanted to, we were on the east coast and we wanted the waves to propagate from the east to the west, then we would flip this by 180 degrees. We would click OK, and what would happen would be that we have another wave grid, and this time the point of origin is in the upper right hand corner instead of the lower left hand corner. And then we could save this grid as the one we want to use. So that's basically covering the two methods for generating these flow grids. One from the map module with refine points, and the other from an existing flow grid, assuming that it is a variably spaced flow grid. Are there any questions on any of this that I've covered? Do I need to go back to before I had the little glitch with the audio and video? Okay, if there are no other questions, I'm going to move forward here. So the next thing, there's another question that says, how do we bring up the IJ orientation? That's this IJ triad that's located here. That I got from the display options. So it's under display, display options. And for the Cartesian grid, there are several options here, but one of them is IJ triad. And so you just check that box and hit OK, and it'll appear wherever the point of origin is located. All right, so I think I will go back for just a second and go back over one of the options that we had talked about before I got a little messed up with the audio. So let's delete this back off. I'll just close all of my grids here and just move forward from the bathymetry. So I have got my scatter data, which is my bathymetry. And so what we would do is we make sure that we have a map coverage. So we create a new coverage for the waves. And select CMS wave as the model. Click OK. And so now we select that coverage. We can create a grid frame, which is this purple box in the tools. And so we want to start in the offshore, in the deeper water, and move towards the shoreline and then up towards the other edge of the domain. We can then select the grid frame and move it to wherever we want to. So I'll just leave it in this location. I don't need all of this bay for waves. And then I've got my location here. Then I can create refine points, and I'll just put a couple of refine points in places where I think I might need them, similar to what we did on Tuesday. Then I can select those points that I created by just drawing a box, or there's under Edit, you can select with the polygon, so you can click out a polygon if you have a very complex order. Then you can right-click and choose the node attributes, set the refine level. We'll say 50 meters at this point. And then we're ready to build the grid. So it's under Map to 2D Grid, which is under the Feature Objects pull-down menu. And we'll choose Refine Points. We'll give it a base cell size. I'm just going to choose 200 at this point. 200. Turning off the inner growth, and then choosing a scatter set. Making sure we have an extrapolation value. And that's basically for all of the locations that are not covered with a triangle in the scatter set. That would give a certain value to all of these cells in the grid. So let's go ahead and click OK at this point. I get a message like that, but it's fine. So now I'll turn off my scatter set, I can zoom into the grid, and I've got my wave grid with the IJ triad in the exact location that I need to. I've got -2 used for all this back area because there was no bathymetry. And I'm ready to move forward to the next couple of steps. At this point, since everything is how I want it, I could go up to the wave model and either file, save, CMS wave, and then I'll ask for a file name, or we can do like we've previously done and save a new project. And I've just been using a prefix of webinar for these saves like this, so I just tried that. So if you look in the directory, we have a few files here, all starting with the prefix that I just entered, and that contain these files, which are the wave files, and they have different extensions than the ones that we used for the flow, and that's so nothing gets mixed up and we don't share the same file name for different types of data. So now that that's saved, are there any questions before I move on how to get spectral energy into the dialogues? I have a question, what would be the difference between save CMS wave and save a project? Well, that would be in how these files are saved. When I gave that prefix for saving a project, it saved everything that's in the tree all together. I have one file called webinar.sms that I can load in, and it'll load all of the files that were saved at the time that I saved my project. After you go through the whole creation process and you have all your bathymetry files and your map files, you don't necessarily need to resave those if you haven't made any changes. And so a lot of times what I'll do is, rather than saving the whole project, which may take extra time, I'll just save CMS wave. And so basically what that would do, it would just save the webinar, the wave.sim, and all corresponding other files. So it would only really save these four right now. Once I add spectral energy, there will be a fifth file, and there may be some other files that it would save once you save the wave. So one saves all of the project, which means everything that's loaded, and the other is just saving the wave information. All right, so let's move forward here, and we'll go through the interface a little bit. A lot of the options are the same. You still have the data calculator that you can do different things with. You have CMS wave. There's a few new options here. and one of them is spectral energy. You've got a model control, a model check. You have this nesting of grids, which I'm not going to cover today. And then you can run the CMS wave as well. So under spectral energy, that's how we actually build what forcing we're going to have on this offshore edge that gets propagated towards the shoreline. And so this is where it gets a little confusing to some people. You have a numerical model grid that's here, but you also create a spectral energy grid as well. And so to do that, we need to create this. These are the defaults, and normally we suggest that you leave those alone. You are able to modify some of these values, but for the most part, the default values are what you need to use. So you just click OK, and it creates this spectral energy grid, which is basically from about 85 degrees in one direction to negative 85 in the other, all normal to your shoreline. And so your energy will be propagating in from these edges. So once that's created, you can do one of two things. You can, if you have the bulk criteria, which is the wave height, period, and direction, you can create a spectral energy from those discrete values, or you can actually take information from a wave gauge that may be a CDIP buoy or a NDBC buoy, some information like that. We have certain utilities that we can use to take that information and orient it in the right direction and get it in the right format for reading into SMS. But the first step I want to show is to just generate a spectra from wave criteria. So we just click the button for generate a spectra, and we get this dialog. So it asks a couple of things. There's a few different ways for generating the spectral energy, the default being TMA, shallow water. There's some others that you need a lot of other information for, but just for a generic wave, we just recommend using the TMA generation method. You would specify what the offshore depth is for your grid, and I'm not sure exactly what this is right now. I can go back in a minute and find that out. But I think it's around 60 meters or so we can put that. And then we start listing these lines of discrete instances of waves. So our wave model doesn't continuously run from through time. It's actually modeling one point in time every time it runs. So what we do is we try to get representative wave conditions for certain time periods that we're wanting to simulate. So this first one, you can give it an index, and it can be any number value. Sometimes we put in kind of a code so that we can tell what time this particular wave condition may be equivalent to in real time. So it could be something like 2009 November 30th at 0000 hours, something like that. And so each individual time like that we would go through, and then to us it would appear that's what that time was. This is a separate time, this is another time. You'd give it a certain angle, and that angle would then be shown in the dialog so that you can make sure that the projection and the orientation that it's coming in is correct. If you're pulling in values from a file, say from Excel spreadsheet, sometimes those directions are for different conventions, and so you would look and see what these angles and make sure that they're appropriate for what we're doing. So there's a shore normal, oceanographic, meteorologic, and Cartesian, and you see these values for the angles are changing in between those. So you would find which one is representative of that direction and then be able to change back to shore normal or whichever one you wanted to use. Then you could put in height in meters and then some kind of a period. I'm just making this up off the top of my head, but you would have some idea about your wave climate for your given region and know what the waves that you're trying to model. So then there are a couple of other options here for gamma and NN. Sometimes this information comes from the wave gauges. If you don't have that information, there's another button for spectral defaults that you can actually come in, and it gives a value for each period that you could use. It's a typical value. And then you could just keep loading these. Once you're through, just click Generate, and then you'll have a list here that has all of the points that you just created, and the first one, and you see a representative energy. That you can look at, and you can, the same thing as you can with the normal grid, you can change and look at it color filled, specifying a range. This range is in hertz. You can actually rotate this. There's a rotating option so that you can pull and look at what the spectra looks like, the shape. Another thing that you could do if you didn't want to do that, there's a couple of plots that you can get that come up for the energy versus frequency and direction, and that's a little bit more information. So are there any questions about specifying individual wave criteria in this method before I move on to the other? There's one question that says CMS wave doesn't read in time series like ST wave and SWAN. ST wave is just like CMS wave. It is a steady state model, so it's reading in individual wave criteria that it runs. They may have a file that has all these in there, and it'll read those in. CMS wave and ST wave file format, at least for the half-plane model, is almost identical, if not exactly identical. So yes, it can. As far as SWAN, I'm not really sure. I've not run SWAN in a long time. But you're not doing your waves through time. You're doing them for one in particular time. So that's kind of how we give it. We would like to, at some point, be able to have a better representation of the time as an actual date, so that later on when we get into the steering, we're running these waves when we want to, and rather than at a specific interval. I hope that answers that one question. There's a question on directional spreading. How is it determined? That basically is when we created our grid, our spectral grid. I'll delete this back out and create it again. This frequency distribution you can modify, but not the angle distribution. And so the directional spreading is governed by these values here. 5 degrees from a given minimum and maximum. And right now, you're not able to modify those. Any other questions before I move on to the next method? Okay. Well, there is another way to handle the waves. Like I said, if you have a wave gauge or some other buoy that is out there collecting wave data, there are several different locations, and I don't have them all listed here, but basically one location that we can go to is, there are CDIP buoys, there's NDBC buoys, And so there's various locations where you can go on the internet to grab information for your waves. Trying to remember exactly where these gauges are located. But once you pull this information for these gauges, it comes in a certain format. It's going to take a little bit to get in there. I'll just select one of these. You can view the details on these gauges, and then you can actually download the information, and that information comes in, and I have an example of one of these right here. This one I show on the screen is 46006, and we've already got the data for a different gauge downloaded. This is for a time period in 2007, but I'll open this up so you guys can see what that format is. And it's very hard to read. So if you had to go through this and pick out what the wave period, the wave direction, and all the other information for this particular time, it would be very hard to do that. So we've got some utilities that are available on our website, and I'll go to that real quick. Basically, you go to our wiki page. We have a documentation portal on the left, and on the right in the columns over here there are some utilities, and we list a lot of these utilities in there for various things that I'm not going to actually cover today, but some of them are listed down here for wave transformation. So we have different utilities to take WaveWatch 3 spectra and format it in a CMS wave format, a WISP wave, CDIP, and NDBC buoys. So you can download these programs and run them with the data that you download from these sites, and then wind up with files that you can load in to SMS that are representative of that wave. Let me see. Let me go ahead and do that real quick because I don't have the energy file here for this one. So I'll go back in there again. This is NDBC, and I'll download this file. And then I can run this program. And we've got some direction on the wiki on what the steps are for this, but basically you'll go through and you'll give it a name. In this case I've got 46022, and then you give it a starting time, an ending time, and or you can just specify all nines for just through the end of the file. And then you can actually go through and pick out if you want hourly or 3 hourly, 6 hourly data, or if you want everything that's in the file, you can just enter a 0 there. I'll pull out hourly data, so I'll just put a 1. And I'll tell it to write a CMS wave spectral file. That's the option number 2. We can give it a file name, and I'll just name it Humboldt.eng. And then it's asking for the local shoreline orientation in polar coordinates. And this is something that you would get from your grid. You would find out what the orientation is. You could right-click. Actually, it's under File, Get Information. There's a certain orientation that it gives here, this 328.91. But if you have saved your grid and look in the file, there's an angle right here as well. So that's the angle that you would put in there, 332.0454. So I'll make a copy of that. And enter that. Then we get the offshore buoy depth. And I'm not sure what this exact one is. Let's see if I can find it real quick. I think I closed that page. So the offshore depth for this particular one is 674 meters. So I'll put that in there. And then what it's asking now for is this seaward depth, which is at the edge of the grid, and we have 60 meters. You can include wind if you want or skip it. I'll just skip it in this point. And it'll ask for how many frequencies. I'm choosing 30 frequencies. And so it's finished now, and it's written some files out in your directory. And the one we're mainly interested in is the one with the .eng ending. And the format looks like this, which is exactly like the format that ST-Wave uses for its half-plane model. And you notice that the index here at the beginning of this line is representative of the year and the date. So this is 2007, December 1st at 1 o'clock in the morning. So at this point, we have the energy file, and we can go into spectral energy. Instead of building a grid, we can actually import this energy file, so we'll find it. And that's the one I just created. I'll open that, creating a new spectral grid. And it lists all of the information that we requested that's in that file. So if we go through, we can look and see what this looks like. So you can see that they're not symmetric wave spectra, and you can tell that these are real spectra that came from a gauge out here. And so you would want to just look at this, and this would also show you whether the directions are correct and things like that. If you needed to edit these spectra, I believe you can right-click and go in and edit, and it has all the information for those particular ones from the file. Are there any questions about importing spectra from these various gauges? One question was about the WIS Hindcast database. As you see, there is on that wiki utility page, let me go back down there again. There is an option for WIS wave spectra and these other 4 options. So if you get the information from the WIS folks, you can use that information to force CMS wave. Absolutely. Hong Hai is requesting to show you guys something, so I'm going to give control to him for a second. But I guess he's not going to do anything. Sorry guys, not exactly sure what's going on here. I'm going to take control back. All right. So are there any other questions before I move on to the next section? It's pretty straightforward. We tried to be able to handle information from most of the gauges around the United States. I'm not sure if we handle any gauge types or formats for those internationally. So, but this is basically how you get this done. Now, once that's loaded, we have our spectral energy loaded. We can go in and look at the model control. I showed this briefly the first day, but basically we have options to specify a forward reflection, a backward reflection. So that would be when the waves come forward and hit some structure, whether or not the waves could bounce either forward in the domain or backward in the domain. There's some options there. Wrong tool here. So we go to model control. There's also a muddy bed, which basically the user can set up with some parameters that affect how the waves propagate towards the shore in those areas. You can select different wave breaking formulas, with the default being the extended GOTA formula, which is normal for most of the cases, but you can try different ones if you want a little bit different result. And you can tell it to output either the breaking indices or energy dissipation. Normally, if you're going to be running with the flow model, then the dissipation is what you're wanting to get out of this, so that will feed directly back into the flow model. We have a bed friction, and right now it's set to none. So if you want to represent some sort of bed friction, then you would specify whether it's a friction coefficient or based on the Manning criteria, and various ones of these. We have a constant over the grid. We also have a variable, and that requires a data set to be loaded into the data tree. So if you want a constant bottom friction, that's what you would use. Various solvers, and these are explained a little bit in the wiki, and may be covered next week a little bit in more detail. There are wetting and drying that can be included, a nonlinear wave effect. You can turn on run up, and that's basically as the waves are making their way towards the shore, they're going to run up onto the beach a little bit, and you can get some of that effect and pass that information back to the flow model. If this is turned off, then basically there's no wave dissipation, radiation stresses, or anything after the waves get to zero water level. Anything above that, there's no action. There's an simple infragravity wave effect that's been added recently, and you can also choose to change the diffraction intensity a little bit if you need a little bit more or less intensity. You can turn on currents, and you have to pass this information. Normally this is done automatically in the steering module, which we'll cover either later today or tomorrow. You can turn on a spatial wind field, adding in winds. There's another way to do this, and I'll go over that in just a second. And then you can also add in a surge file. We can pull in wave source, whether we're coming only from the spectra that we loaded from that gauge or by the criteria. There's some parameters here that we can specify for each one of these. Adding in a tidal elevation. That's basically what this surge is, spatial surge. There's wind that we can specify, wind speed, direction, and then that same tidal elevation. You can have a combination of both the wind and the spectra. And then you can also change this to a simplified formulation that changes the gridding from the spectral energy gridding from this 30 by 35 grid down to a 7 by 5 grid. So you're kind of making it a little bit more efficient by reducing the number of bins that it's got to go. But it's a much faster answer, but it may not be quite as accurate as needs to be. So the output, I guess what I need to say about this also is the simplified formulation might be good for the first initial attempts to run with the waves, but for an actual project or the final answer, you probably would want to go and use either the spectra or the spectra and wind options just to make sure that all the possible information is captured that you need to. There's some output options, turning on the radiation stresses. Normally this is automatically done for you for the steering module. And then sea and swell information, you can output that as well. And you can output in either ASCII or XMDF. The XMDF is just a binary format that makes it a little bit easier to load these solutions. And that's basically the model control dialog here. Are there any questions about model control? I've got one question about what does the sea/swell control do, and I'm going to let Liwa write you an answer. Maybe he can forward that to the entire group. That's a new option that I'm not exactly familiar with. So I'll let him answer that, and if he can choose to share that with the entire audience, that would be great. And I'll learn something too. Another question, is there any way to have a scenario manager for model control if you wanted to have different input conditions without having to save many copies? Basically, all of the input conditions that you want in the model control as far as the wave spectra, I think that's what you're asking. All of that is kept in one file. If you're talking about various ways to have different types of running different conditions with different reflective coefficients and things like that, the answer is no. There's no real way other than to create multiple copies, each one taking on its own either name or a new directory, so that you can keep track of your different changes that you've made. As far as being able to output the spectra, I don't think that there's a way to output the spectra on a global way at this point. You can only look at what's being forced on the input side. Okay. Well, if there are no other questions for right now, we can come back and answer a couple more a little bit later. It's a little after 2. I want to go ahead and go into the next little portion. Actually, we're way ahead of schedule today, despite all the few glitches that we've had. But so let's go into actually going over how to run both the flow and the waves together. And that's done for right now. There are two ways in SMS 11.0 to do a steering. And it's basically if you are using an explicit grid, explicit flow grid with waves, you have to do it one way. And if you're running the implicit model with waves, you have to do it a little bit differently. So let me just load in a flow grid real quick. I think I might have one in the same directory. I'll just get rid of what I created. In the directory I have flow_hb.cm cards, and I have a wave hb.sim. And so essentially what you would do is you would load both the flow and the wave grids. You would want to make sure that your wave grid is a little bit larger or the same size as your flow grid. That would be the preference to do that. If your wave grid is a little bit smaller, that's fine, but you have to decide what to do at the edges of your wave grid. Say the wave grid ended at some portion, you'd have wave action inside, and then wherever the wave grid stopped, you'd have nothing going on the outside, so you'd have some disparity there. So what we tend to do is we extrapolate the values that are calculated inside the wave grid and force them laterally some distance. And you can specify what that distance is, or you can let CMS choose that automatically. So basically, now that we have the flow grid loaded and the wave grid loaded, we'd want to make sure that in each case we have our model control set up exactly how we want to. So we'd have that. We'd make sure we saved the grid. We'd go into the flow grid and look at the model control. Make sure our timing and the time steps and everything is okay. Okay, and in this case we're using the implicit scheme, so I'll go over the method for that. I'll just look around and make sure that everything else is kind of set up okay. I need to make sure whether or not I have a forcing condition assigned, and I do. It looks like it's just a constant tide in this case. And so the next step would be to save your flow grid, and then you could go to Data, and there's an option for the steering module. And so under the steering module option, there are two choices that you can make when you have CMS flow and wave grids loaded. One is CMS flow with the little to and from CMS wave, and basically this is the option that you would use for the explicit model, and then the CMS inline is what you would use for the implicit model. And so since I had specified in the model control the implicit model to be used with an implicit time step of 600 seconds, I'm just going to choose CMS inline and click Next, and there's a few options for you to choose. And so depending on what you have loaded in the data tree, you could make sure that you're using the right flow grid and the right wave grid, and you'll tell CMS to run every X number of hours. And this interval needs to be represented in how you specified your spectral energy dialog. So I'm just going to go back for my own benefit and double check and see what that is loaded. So let's go over here to waves. wave spectra. And right now I only have 2 times loaded. I'm just going to get rid of this and import that spectra again. All right. And these are set up for a certain time, 2007, December 1st. And so what you would want to make sure is that both of your flow and your wave grid are set up with information for the same time period. That's just a manual check that you're going to have to do. So I'll go back over to the flow, and if you remember, the condition I had out here was just a standard, looked like an M2 tide of some sort. So it's just a made-up tide. But normally you would be getting this information from either a gauge of some sort that's specifying the water surface elevation or using tidal constituents, and you want to make sure that that matches up with your wave information. So also in the model control, you would want to make sure that your starting date is the same as that is what you're trying to use. So I think everything else is situated okay. I'll come back and save the flow. I'll just go ahead and save everything under a new project. I'll just call this webinar 2, just so that I don't make any different mistakes here. And now I should be able to go under Data Steering Module, CMS Inline, and select that was hourly data. So I'll change this to every 1 hour. And all of this is grayed out because we're passing as much information back and forth as we can. We don't necessarily have the ability to change these anymore for the implicit. I think these are still available for the explicit steering. So let's start. We have, just to make sure you're running with the wave model every hour. And so it's going through and running the waves first. And it's a big wave grid, so it may take a few minutes to do that. Let me actually go back and I'll select the simplified formulation, and so this will go a little bit faster for us for right now. So I'll abort, go to the wave grid, resave it, go back to the flow model, and then choose steering again. And so now you see the waves are moving through much faster than they were. And the answer is still approximate. It may not be the best, but it's very close. So what this is going to do while it's actually doing it, we've specified a number of wave conditions, and it's taking the first one, which is what it just ran there, and it's now calculating a distance, an extrapolation distance automatically. And that's because CMS is doing all the mapping from the flow to the wave grid itself. If we did this from the other option, SMS would actually do all this mapping back and forth for you. So this will take just a second, but it's choosing the first 2 wave conditions. It will run those, and then it will actually run the flow model between those 2 times. So when the flow model is over for that hour, it'll run the 3rd wave and then run another flow period. It's a little bit hard to describe. I may be able to find a PowerPoint that shows that a little bit more, and I might bring that in tomorrow. So this calculating the coefficients for the extrapolation is a one-time thing. As long as you don't change your flow grid or your wave grid, then these values will only have to be calculated once. The next time you run, it will actually find those written in the directory and use those. And this can take a little bit the very first time to run this. I should have tried this ahead of time so we didn't have to wait. But this may take a while. I'm going to just stop this right now because I have no idea how long this particular part of it is going to take, and show you how to do the explicit steering. So I will abort this, and I'll go under the flow model and change to explicit. And then I must change my time step because there's no way the explicit model is able to run at a 600 time step. So just to be on the safe side, I'm going to run with a 0.75 second time step. I'm not exactly sure what should be used here. It's just you run something, and if it crashes, you try a different time step a little bit lower, and hopefully that runs a little bit easier. It's a little bit more difficult to figure out what the appropriate time step is. So I'll save the grid, and then I'll go back under Data Steering Module, and instead of choosing the second option, I'll choose the top option. And all of the information is the same. I want to pass information for currents and water surface elevation to the wave model. And also from the wave model, I want to pass the wave data to the flow model. And then I'm choosing to extrapolate some distance. In our case, they're exactly the same size, but you could put some value here. It's not going to add any type of computational time for this. So I'll extrapolate that out and start the model running. And there's a little bit different dialogue because CMS is handling the mapping. And so what this first dialogue is, the first wave run, you're looking at the average wave heights as the waves are being propagated from the offshore towards the shoreline. And you can see where it broke and another smaller break. And then a second wave condition is going to be run, and it'll show that one. So it's similar to how it was just shown a second ago. And now that both wave conditions have run, it's going to start running the flow model. And so depending on the time step that you have and the length of time between the wave intervals, you'll see a CMS flow progress down here. And so now it's finished 8%. As this is running, I'll just look in the directory where I'm running, and you'll see a couple of files that have been created. So running the explicit model creates one set of files for the first wave run, another set of files for the second and third and fourth. So you'll wind up with many files in your directory. There's no way around this at this point. It also gives you a copy of the screen output, what normally would be showing on your command prompt. And then also there's another file that says other information about the running of the different models, the wave model and the flow model. And if there was a crash, one of these files will have that information. There's also an informational file from CMS that basically says what the setup was, and then as it's running, it actually updates this file. While this is running, are there any questions that we can answer quickly? I'm going to let this run for a few minutes, and then we'll have something to look at and pull in and see the different types of file outputs. Okay. This will be finished in just a second. And tomorrow we'll get into a little bit more of the post-processing. So we'll load some solutions and be able to generate animations for those, be able to save the information out to a KML file and be able to look at it through Google Earth. There's ways to look at extracting information from your solution for given points, and so you can look at the water surface elevation curve and pull in and look at that compared with an actual measurement. So this will be finished in just a second, and I will stop it, and then I'll pull those files in and show you a few more of the various options for looking at the data. It says that actually the run was unsuccessful, and so we'll have a chance to figure out what that is. So if we look at the CMS diagnostic file, saying cannot create hot start info data set. That's interesting. I must have had hot starting turned on in the model. So it tried to write out a hot start file at 1 o'clock, after 1 hour, and it was unable to for whatever reason. I'm not sure what that might be, but it looked like the actual run finished correctly. And so we can actually load this solution file. This is a solution for the flow grid, as we see. So we can come in and look at our flow, and it's actually loaded our results for us. So we have two different things that we chose to look at, and one of them is elevation, water surface elevation, and the other is current velocities. And you can see down at the bottom that we have 3 time steps available to scroll through. One is just a 0 time step, one is after 30 minutes, and then one is after 1 hour. And so what we're seeing on the screen is the actual water surface elevation, and I've got a large range because I had saved that for my depths. So what we can do is right-click on this data set and choose to change the contour options for that data set and show them however we want. So we can look, and I'll just go from a symmetric range, say minus 0.5 to 0.5. And so we can see deeper water in the ocean side and a little bit shallower increase on the bay side. And so if you had a long series here, you can scroll through these and look at how the tides are propagating in and out of the area. I'm going to change this a little bit. I'm going to turn off my cell strings and some of these other symbols and actually turn on the vectors. And then I can change how the vectors show up. So there's various options here. One for every node in the grid, which that can get very busy. What I normally choose is on a grid. And then you can define what spacing you want. So either 15 or 20 pixels apart. And then I'll show in a minute what the Z offset will do for you. And then you can show a different range if you want, from 0 to 1. And then how the arrows show up. So I'll just choose this for right now, and we'll see what they look like. And so if I zoom in a little bit, you notice a lot of these arrows are hidden, not quite as easy to see. If I go back into my vector option, I can change the Z offset to be 2. And basically what that does is it raises the vector field 2 meters above the elevations of your solution here. So what was happening was the tides were above the mean sea level, but the vectors were represented at that 0 level. So they're kind of covering up these vectors a little bit. So by lifting those vectors, you can actually see everything that you need to. So if we had a longer time series, we'd be able to see a little bit better action, what's going on here. This is early on in the solution, and so there's not much going on at this point. The current through here is right now is only 0.4 meters per second. Through Humboldt Bay, we often get above 1 to 1.5 meters per second through here during some particular time. So, are there any questions about looking at these elevations? What I'm going to show now is sometimes you don't want to look at the water surface elevation. You want to actually see the magnitudes of the current speed. So you can find the areas where the flow is the strongest through certain areas. And one way to do that is to right-click on the vector data set, and there's an option to split the vector data set into 2 different scalars. And so we'll choose that. We can choose magnitude and direction and give it some kind of a prefix, and then click OK. And it'll go through the entire data set. It'll split them into 2, and then you can look at the magnitudes along with the velocity vectors. And once again, I've got it set between 0 and 20, so we can modify this. It's some very small number at this point, so we can go from say 0 to 1. And look at them as a color fill. We'll click OK. And what I normally like to see, I don't know why these are all 0 actually. This looks like a bug that we found in the interface. I'm going to choose a different way to develop these magnitude and directions and see if that does a little bit better job here. I'll delete these off. So if I right-click and delete that, I need to write this down, report a bug. All right, and so what I'm going to choose to do, there's another way to do that, and that is under the data set toolbox. There's a vector to scalar, and hopefully this one works a little bit better. So you would choose vector to scalar, choose the actual solution, and then you can choose any of these options, and I just want the magnitude. and I'll give it a prefix, and hopefully when it comes back we actually have values here. And we don't. Okay, so I found some issue here with this version. Yours may be working. I have revision 0.07 of SMS 11. I want to say this was working at some point earlier. But that's the basic process that you would go through to do that. It's a little aggravating. And there's various other things that you can look at as well. You know, if we had a run with sediment transport turned on, there would be other options available to us that would be concentration, sometimes the capacity, depending on what type of features that we selected in the model control. And so you can look at all that information and then build an animation if you need to. There's one question that says, when the model was run in an explicit mode with CMS flow to CMS wave and the wave profile was shown on the screen, which was read into CMS flow? Where was the wave profile taken from within the grid? I'm trying to understand the question a little bit better here. So basically, the information that gets passed from the wave grid to the flow grid, if I go into that steering module again, it's passing the current, the flow velocities and the water surface elevation to the waves and the wave information back to the flow. It's also passing, if we look at the files that are used, the radiation stresses, actually the radiation stress gradients are passed and applied to the flow grid as well. I don't know, is that answering your question, Lauren? Oh, okay. So I see what you're saying. The screen that was showing as the waves propagated from the offshore to the onshore, it was showing a value for the average wave height as it moved forward, and that's taking every cell in that row and averaging the value, and that's the value that it's showing there. Okay. So is there anything else that I can cover here? Let me go over and show, it's going to be a short one, but show a little bit of an animation for this run and how to set that up. One thing that you can look at down here is we have this odd time associated with these time steps. And basically this is some number of hours after some arbitrary date that SMS has used. And I think it's a date that all the programs use as a reference. But what you can do is you can right-click on this window and set your time settings. And so you can change to show from relative time to an absolute day and time. And this kind of shows what the difference would look like at the bottom there. So this is what I normally do so that I know exactly when each one of these snaps is 4. And then when you go under Data into the film loop, you have a couple of options here. You can create an AVI file, which is basically just your standard animation file. You can give it a name, or if you don't give it a name, it will default to sms.avi. You can also output this to a KMZ file so that it can be read into Google Earth. So I'll just try both of these real quick. Like I said, it's going to be very short. And we want a transient data animation. We'll click Next. And then you have a chance to go from the starting time to the ending time, change the number of frames, change how frequently you want the output. If you want to see every hour instead of every half hour, you can do that. If you want to see every quarter hour instead of every half hour, you can do that as well, and it will interpolate between the two and give an actual value for those times. I'm just going to leave it with these standard ones here. You can change the time zone to whichever area you're working with. Actually, this is very new. I've not seen this before. So for Central Standard Time, we've got Chicago. We're going to be actually in Pacific Standard Time, Los Angeles. I'll click Next. And then it goes through and actually goes through and builds the animation. Well, there's another step here. You can turn on a clock that would appear somewhere in your screen. So you would show a progress bar. There's various types, a horizontal or a vertical. You can change the size of those. You can actually show the time underneath there, some other information. And then Finish will generate the grid, the animation. And so it actually starts after it's finished, starts the animation. And you see the clock where I chose to put it actually is over the legend, so we would want to move that at some point to a different location. But not only does it build the animation, since I asked it to, it went ahead and saved the KMZ and opened it up in Google Earth that I have loaded on my machine. And so through this, you could actually go through and see the various snaps through time as well. So let me regenerate that animation real quick. I'll turn that one off. It now sees that there's a SMS AVI in the directory, and it renames this one to SMS2. We can keep that. And then I'm just going to choose to put the clock in the upper right-hand corner instead. All right, and you notice this goes very fast. There's only 3 frames, and so you can change the speed with this AVI player that they have built in. Are there any other questions so far about what we've covered? I don't necessarily want to get into any new topics at this point. Tomorrow we'll go a little bit deeper into post-processing, and we'll have larger files to work with. We'll get into comparing some of the output with measurements, maybe get into statistics a little bit, and then we'll probably show a little bit of some of the newer features that are coming in the next version of CMS and SMS 11.1. later this fall. So go ahead and start asking any questions. If you want me to go back over anything, I'm able to do that with no problem. Alex or anybody else, is there anything that you think I should go over? If you could let me know in the chat window, I can do that. Okay. There's another way to run the CMS, and I showed this a little bit yesterday, which is to run maybe not yesterday, the day before, which is to run the CMS from the command prompt. You can't really run the explicit model and the standalone wave model from the command prompt and still get the interactive steering, but you can do the steering with the implicit wave model since everything is in line. And so what you can do is go ahead and into the model control, we'll change this for implicit. We'll change our hydrodynamic time step, and I'll actually turn off this hot start output file. And when you run steering for the implicit model, it writes a couple of extra card files, a couple of extra entries into the parameter file that basically says that you want to run with waves and at a certain interval. And so what you would do is you would enter these cards into the advanced section. Adding in the steering interval. Let me see exactly what the names of these cards are. There is a list of some cards in the wiki that are basically what is contained in the control files. And so if we look in the CM cards file, all of these cards are listed in that. And what we would want to do is add a couple of more into this parameter file. So to do that, we add a card into the advanced section, basically saying we want a steering interval of 1 hour, and then we'd add another line that says the CMS wave sim file and give it a name. And so we want to name this particular file, which is the sim file. That's the actual parameter file for the waves. So we take that name and put it into this blank, and then click OK. When we save our model, that information gets written to the corresponding parameter file. So I can look in this, and now at the bottom of this we have 2 extra cards. And so now we're able to run this from a command prompt. And so to do that, we'll start, run, we'll change to the directory we need. So it's this one. So I'll switch to the F drive. and I'll change directories to that location. And then we need to make sure that we get the right executable. So I'll find in the folder the program files where SMS 11 is stored, looking in the models, the flow directory, the implicit 64-bit on my computer, and we'll copy these two files from that directory over to where we're wanting to run from. And so then we can actually type in the name, hit our tab key until we get the right name, hit a space, and then we're looking for a certain parameter file. So that's called webinar 2 flow CM cards. We can do the same thing, webinar. So at this point, we're telling CMS to look in the CM cards file and run with whatever options are specified. And so as we do that, it sees those cards and is now running the wave model a couple of times like we did earlier. A lot of times it's just as easy to open up the card file and hand edit it and add these two cards in there directly, especially if you're comfortable with running from a command prompt. You don't necessarily have to do everything from within the SMS interface. I think we brought that up the other day, that it's easy to change these cards here and there. One other thing I could show is how to bring in the wave results. So once this is done with the first one, I'll stop it and actually load in some of those wave results. I realized that I showed the flow, but I didn't actually show the results for the waves. So let's just take another second or so. Then I'll just stop it. So when we have our runs complete, that happened because I actually overwrote the solution just then. So I'll load in the wave results, and this is from the standalone wave run. And what we can do is just pull in. You can select the wave grid, and then if you just want to look at the wave results from the first one, you can pull those in directly into the interface, as long as they line up with the grid that you have selected. Same thing goes for the vectors. You can go in and change these vectors. Looks like I have to lift them up a little bit higher because the wave started at 2 meters. So let's just try 5. And we'll choose the entire range for the height. And so what this is showing is the waves and the direction. We don't necessarily get a lot out of looking at directions, but we can also look at the period of those waves as they move towards the shoreline and into the bay. And we can also look at the wave height. And so if I zoom in, as we run our cursor over the screen, we can see that the wave height here is 1 meter, and it works its way down and then crests again. So let's change the range here. And this should show it a little bit easier. And so you see the green colors are about 1 meter up to some bluer. You can see where they're peaking a little bit in different areas. You see the directions. And then as it moves through, the waves move through the inlet, the directions change a little bit, and the intensity, of course, changes. One thing that's lacking right now is combining all of the waves together. When they're run in the standalone method, all the waves are in their own files, their own directories, and we need to find a way to get those combined. And so in the next version, when you bring these in, they're all together, or will be all together. One question is, when you begin steering module, the wave and flow grids must be similar in size, larger wave grid. Must the grid spacing be the same? The answer to that is no. The spacing is totally independent of each other. You do want to have a large enough spacing to represent what you need. It looks like Alex has already answered this, but that's not necessarily the case. They don't have to be the same. As far as the wave radiation stresses, you can also pull in those as well. Let me shrink this back here. And so those are carried in the .rad extension. And so you would load those just as you did the wave. And now the wave radiation stresses are shown here. You can change the way those vectors look. So let's just look at all of them. You can change the length for them. Okay, that wasn't a good idea to look at all of them. So let's go back and change this again. All right, and so now you see the areas where the radiation stresses are greatest, in the areas where it's breaking, where it's nearest shore, reflecting, things like that. So hopefully that answers all the questions for right now. I'm going to go ahead and wrap up for the day and see you guys tomorrow for the final day. Be thinking of any questions that you might want us to answer. Since this will be the last day of the basic, if you're not showing up for the advanced, or if you didn't register for the advanced webinar and you want some answers, you can also just email us directly. I gave some emails earlier, email addresses in that first set of presentations, so just email us directly, or just find the ask the questions when we get there tomorrow, or if you're going to be here next week, then you can ask some extra questions then. But if that's all, we're going to go ahead and wrap up for the day, and I'll see you tomorrow. Thank you, guys.